Now we begin to describe the method of analysis for the determination of urinary catecholamines with a fluorometric detector. This method has been developed because of the problems that can be found when using an amperometric detector, as I've previously described, particularly the difficulty in managing the amperometric detector and the long sample extraction procedures with consequent loss of time to carry out the analysis. The objective we set ourselves was to simplify, improve, and standardize the analytical procedures used in clinical laboratories. What do you need for this analysis? An isocratic HPLC equipped with a fluorometric detector, ready-to-use kit complete with lyophilized calibrator, the lyophilic controls, HPLC grade water, variable volume pipettes and micropipettes, pitchers, pasta pipettes, plastic tubes, reduced volume vials with caps, a vortex, litmus paper or pH meter with electrode, the 24-hour urine samples suitably acidified with the indication of diuresis, the installation and conditioning of the column according to the specifications of the manufacturer. We take as an example an analytical session of 7 urinary samples on which the catecholamine dosage should be performed. Along with these samples, we will also analyze one well-known lyophilic calibrator that will be used to automatically plot software the calibration curve, and 2 lyophilic controls, level 1 and 2, which will be used to control the validity of the calibration curve and that of the whole analytical session. First of all, we prepare the HPLC. The instrument must be cleaned from the previous analysis. We connect the clean analytical column to the system. In the mobile phase, reagent M, we put the floater and let the pump flow at 1.0 milliliters per minute for 10 to 15 minutes. After this, we will be ready to make the first injection. With analytical systems connected to an amperometric detector, this would not be possible. The times are much longer, and this loss of time creates constant and daily inefficiencies in the laboratory. In addition to this, you will find that there are other benefits that will lead you to gain time. For example, you will now notice that the steps of purifying and extracting catecholamines with the method I will show are very quick and simple, because you are using a resin and not an SPE column, which requires analytical steps. Let's get to the workbench and reconstitute the calibrator and the lyophilic controls. Transfer 10 milliliters glass or transparent plastic tubes, 1 milliliter of reagent B buffer solution, 1 milliliter either sample, calibrator or controls. Then we vortex for 20 seconds. Verify the pH of the processed samples, calibrators and controls that must be between 7 and 8. Adjust them if necessary with the addition of a little sodium hydroxide. We invert the reagent A resin bottle. Transfer into 10 milliliter tubes 500 microliters reagent B1 purification buffer, 500 milliliters reagent A purification resin, 1000 milliliter samples, calibrators and controls prepared earlier, 50 microliters reagent H internal standard, vortex for 20 seconds. After this passage, centrifuge at 4000 RPM for 2 minutes. At this point, We aspirate the supernatant with a Pasteur pipette, or alternatively, we quickly invert it. Be careful not to pour the precipitate present in the bottom of the test tube where our catecholamines are captured. Now, pipette, 2 milliliters of reagent C, extractive solution. Vortex again for 20 seconds. This is the most important step because it will remove the catecholamines from the resin, so be careful to observe the time indicated for vortex, i.e. 20 seconds. Centrifuge at 4000 RPM for 2 minutes. Now the sample is ready to be derivatized. You'll notice that the phase of purification and extraction of catecholamines are very quick and simple. This is because we used a resin and not an SPE column. Let's now proceed with the derivatization phase, which will further increase the sensitivity of our method. We continue and pipette into a vial 200 microliters of sample from the purification procedure. 20 microliters of reagent D starter, 20 microliters of reagent E derivatization solution. Then we vortex for 20 seconds. Finally, we incubate at 70 degrees Celsius for 15 minutes. During the incubation phase, to derivatize the catecholamines, we can complete writing the workbook on the software and put away all the reagents and material used up to this point that we will no longer need. After 15 minutes, we remove the vials containing the derivatized catecholamines from the oven. Wait for a few moments to cool and add to each 300 microliters of H2O. Then we vortex again. The sample thus prepared is stabled for 7 days in a refrigerator at 2 to 8 degrees Celsius, unlike the eluate used in the amperometric method, which is usually stable for about 24 hours. We are therefore ready to perform the injection of the entire analytical session. Let's move to the HPLC system and activate the instrumental method Eureka Kit Catecholamines in urine so that the system sets the correct parameters. The instrument on which we run this test is an HPLC 1260, but keep in mind that the methodology can be applied to any isocratic HPLC equipped with a fluorometric detector. Following this, we place the vials on the self-sampler, starting with the calibrator, continuing with 2 controls and the samples, and then starting the sequence. When you use the Eureka Kit, you will realize that it takes only 45 minutes to extract and prepare the samples. The chromatographic runtime is 5 minutes, and for our sequence of 7 samples, we will have all the results after 50 minutes of instrument work, including the injection of the calibrator and the 2 controls. This analysis can also be carried out at recycle phase. What does it mean and what benefits does it give to the lab? I can position the HPLC drain tube directly into the mobile phase bottle. In this case, the first advantage is that it is not necessary to calculate if the mobile phase volume is sufficient for the sample numbers of my analytical session. The mobile phase is always retrieved, and so the line will never go dry. Alternatively, I can pick up the mobile phase in a clean container and reuse it in the next working session without affecting the validity of the analysis. In addition, you will have the benefit of having less waste to dispose of. This is a typical urinary calibrator chromatogram where you can see that the peak of the noradrenaline comes out at 1.44 minutes, the internal standard at 1.96 minutes, adrenaline at 3.15 minutes, and finally dopamine comes out at 4.46 minutes. This is a typical high control chromatogram where you can see the peak of noradrenaline comes out at 1.44 minutes, the internal standard at 1.97 minutes, the peak of the adrenaline at 3.15 minutes, and finally dopamine comes out at 4.45 minutes. The time we took for this analytical session is as follows: 15 minutes to prepare and test the analytical system, 45 minutes to purify and derivatize samples, an hour to analyze all samples. With this timing, you can report analysis by 12 o'clock each day and use your instrument for a new analysis in the early afternoon. It's important to emphasize that this timing is valid for analyzing up to 20 samples. If you need to analyze more samples, for example 30 or 40 at each session, you shouldn't miss the next video in which I'll show you a different extraction process that can be automated. Currently, the Eureka kit I have presented is the only ready-to-use kit for dosage of urinary catecholamines using an extraction resin and a fluorometric detector. So let's make a brief summary. In this video, we have spoken of urinary catecholamines and the importance of their analysis for the identification of some adrenal artery tumours, shown the advantages of the fluorometric detector compared to electrochemical, demonstrated how to perform urine catecholamine analysis in HPLC with the Eureka kit, which involves the use of an extraction resin without the use of SPE columns, highlighted the speed of the analysis. In the next few days, we will send the method, where you can see recovery method of greater than 98%, a wide range of linearity from 0.02 to 2000 micrograms per litre. Currently, the Eureka kit I have presented to you is the only kit in the world available for fluorescence urinary catecholamine dosage with an extraction resin and no SPE column. If you like this video, don't miss the next one, where we'll talk about derived catecholamines. We will present the dual kit, which can determine the catecholamines both in urine and plasma matrices with the same reagents, getting the same results as I have just shown you. One last important thing. Tomorrow you will receive the report with the transcript of the video you've just seen. I suggest you print it so you can always have it to hand to consult it. Happy analysing. See you again soon.